uh, in this video we'll discuss about the thin and thick cylinders. Okay, what do you mean by thin cylinder and what do you mean by thick cylinders? First we'll go to the introduction to these type of the cylinders here. If you go to the introduction, the first point, if you see that closed containers, normally known as pressure vessels. Whatever the closed containers, for example, any cylinders are there, it will be closing on both ends here. Okay, either spheres, all full closed containers. Those containers are known as pressure vessels. Okay, pressure vessels are normally used to store the liquid or gases. If you see in our day-to-day life here, the whatever the LPG cylinders, that is also type of the closed container. Closed container contains a high pressure fluid here. Okay, so used to store liquid, either liquid or gases, and compressed airs. Okay, these containers are used to store the high pressure liquid or high pressure gases or compressed airs here. Okay, so second point, the example for these closed containers, or normally you can call it as cylinders. Okay, the examples for these steam engines. In our mechanical stream, if you go to that, the steam engines. Okay, as the steam is generated in the boiler, and after generating this boiler, this will be transferred to the engines to run the to convert the steam energy into mechanical energy, right? So at that time, the engine cylinder, whatever the steam engine cylinder, contains the high pressure steam. High pressure steam, also the steam is having temperature here, high temperature. To store this steam, the whatever the cylinders, they are used for these closed vessels here. Okay, so this is one example. The second example, water tank. If you see the water tank here, it is also closed at a particular height. In our the whatever the building, the tanks are there. They are also called as the water tank and stores the high pressure liquid. Next one is steam boilers. As we know that boilers, they're used to store the high pressure steam after converting water liquid phase into the whatever the gaseous phase, that the high pressure and temperature steam, it is stored in the boilers. Okay, these boilers are the closed vessels. Okay, so that is also one of the example for these closed vessels or the cylinders. So next example is compressed air storage tank. As I said, compressor, you know that the compressor, from the compressor it withdraws the atmospheric air, and that will be converted into high pressure air, or the little bit temperature is also increased. That high pressure air is stored in the compressed cylinder, compressed air cylinder. Okay, then it will be transferred to the mechanical, to convert other mechanical work here. So compressed air storage tank also one of the example for these closed vessels here. Okay, so these are all the examples for the closed vessels or cylinders. Later we will discuss what you mean by thick cylinder and what you mean by thin cylinders. Before that, first we come to know that what you mean by the closed containers or vessels. Okay, so next point is these pressure vessels or cylinders, as we discussed, store fluid or gas at high pressure and high temperature. Okay, obviously the whatever the liquid, the fluid is there, it is in the high pressure and the high temperature in the condition. So next point is how the shapes. Normally these types of the cylinder, the name itself it is says that the cylinders, both sides it will be closed and it is in a diametrical shape and it is having some thickness. Okay, normally it is in cylinder shape or spherical shape. Okay, this is how the introduction here. So next, how the these cylinders and the spheres are categorized, that we will see here. Okay, so if you see here, just I'll draw one cylinder here. Next point, this is cylinder, and this cylinder contains a fluid or gas at high pressure and high temperature. Okay, obviously if the fluid is at high temperature and pressure, there is certain type of the stresses will be developed. Okay, these stresses are called the along with the length, there is one type of the cylinder the stress, and along with the circumference there is one type of the cylinder the stresses, that we will discuss later. The stress distribution is like this. See, this is point, if you consider here and here and here and here. This is how the stress distribution. Here, this I'll discuss later. Sigma C it will develop, and along the circumference it will be sigma L. Sigma L. This is in the cylinder, the stresses distribution. If you come to the sphere, this is the sphere, and like this. In the sphere, the stress distribution is like this. Here sigma C it will develop, and here sigma C it will be developed here. This is in the spherical. Okay. So now we will come to the thin cylinders and thick cylinders. So thin and thick cylinders are mainly classified, you know that thin means according to the thickness, right? According to the thickness, how much thickness is there, we have to classify based on that we have to classify these two here. Also the thin and thick cylinders are mainly classified based on the stresses developed inside that. Okay, stresses induced and how these stress distribution along with the length, along with the circumference. But for cylinder, but for sphere it is along with the only sphere. It is sphere, only one type of the stress it will be developed here. Okay, so now we will go to the next condition. The next point, what do you mean by thin cylinders and thick cylinders? Okay, so just I'll write first. Next point is thin cylinders. First I'll go what do you mean by thin cylinder. Okay, just I will write if R divided by T is greater than 10. This is the condition. This is condition. For example, R is the inner radius of the cylinder. Okay, I'll draw here. See here, just the sectional view I'll draw here. This is the thin cylinder, the cylinder. This is inner radius. Just I'll write it as capital R. And outer radius is R0. That just leave it first. First inner radius, because we are feeling the pressure, the high fluid pressure inside the cylinder R. And this is my thickness here. Okay. This is thickness. If the radius of the inner cylinder, ratio of radius of inner cylinder to the thickness is greater than 10, then it is called as the thin cylinder. This is called as thin cylinder. Okay, always whatever the radius it is there divided by thickness, its thickness, it should be greater than 10. It should not be less than 10. Okay, then it is called as thin cylinders. In the thick cylinders it is opposite. In case of the thick cylinder, what is the condition? If the radius of the cylinder, inner radius of the cylinder to the thickness of the cylinder is less than 10, then it is called as thick cylinder. Okay, this is the thick condition. So this is how you have to classify the thin cylinders and the thick cylinders. Okay, so remember these two conditions in while applying the problem or formulae. First check the radius of the cylinder and the thickness, divide. Radius to the thickness is always greater than 10 in case of the thin cylinders, and radius to the thickness is always less than 10 in case of the thick cylinders. This is how the introduction of the thick and thin cylinders. In the next video, we'll derive the expression for the what are the different stresses developed inside the cylinder. We can call it as the circumferential stress and the longitudinal stress. Okay, these two stresses derivation we will derive here. Okay.